Okie doke. In this video, we'll be looking at something called the imaginary unit I. So I, little cursive I. I is similar to pi in the sense that pi has a very specific value associated with it. We know pi is approximately 3.14. Later on in the course, you learn about E. E is another value in math that it looks like a letter, but there's an actual value associated with it. So just like E and pi, I has a specific value associated with it, and that value is the square root of -1. By definition, I squared is equal to -1. You often see it written this way, or I simply equaling the square root of -1. So what I'll do is begin to explore various aspects of this I. And what I'll begin to do is raise I to various powers. And you begin to see something interesting happen. So we'll start with this. We'll first take I and raise it to the 0. In previous courses, you would have learned that any number except 0 raised to the 0 actually equals 1. And in a different lesson, I can show you why any number except 0 raised to the 0 equals 1. So if you have a question, go ahead and pose that. So now I'll continue to raise I to various powers. So we got I to the 0 is 1. We'll take I to the first power. Well, we just saw over here, I to the first is equal to the square root of -1. Continuing, I squared was said earlier, I squared is equal to simply -1. Now let's keep going. I to the third power. Well, I to the third power is the same thing as, let's do this, I squared times I. I'll put it to the first. Well, if we previously established that I squared was -1, and I is the same thing as the square root of -1, so I'm actually multiplying -1 times the square root of -1. Well, any number multiplied by -1 simply means change the sign of the entire number. So that yields negative square root -1. So going back again, I to the 0, 1. I to the first, square root -1. I squared, -1. I cubed, negative square root -1. Let's keep going. I to the fourth power. Well, I to the fourth power means I squared times I squared. Well, we saw I squared was -1, and another I squared, -1. That yields simply 1. So, hey, which is the same thing as I to the 0. That's interesting. Well, let's keep going, see what happens. I to the fifth power. Well, I to the fifth is the same thing as I to the fourth times I. Well, I to the fourth, that was 1. And I is the square root of -1. Well, that yields an answer of the square root of -1, or simply I. Hey, that was the same as this. So it looks as if this cycle is starting to repeat itself. So let's see. Let's do I to the 6th. If everything is on track, I to the 6th should give us the same answer as I squared. So let's see. Let's put it here. We'll go here. Give me some space. I to the 6th is the same thing as I to the 4th. And I'm using 4th because we know that's simply 1. I to the 4th times I squared. Well, I to the fourth, that was 1, and I squared was -1 times -1. So I to the sixth does in fact equal -1. I to the seventh should give us the same thing as I to the third. So let's double check and see. I to the seventh, do the same thing. Let's use the easy ones. I to the fourth. Well, let's do I squared, because that's easy. I squared times I, because 4, 5, 6, 7. Well, I to the fourth, 1, I squared, -1, times I, the square root of -1. Well, -1 times the square root of -1. Yes, in fact, that does give us the negative square root of -1. So in a different video, we'll look at higher powers and show you a quick way to come up with the different answers. So as a recap, there's only 4 different answers we got. The 4 different answers were 1, the square root of -1, -1, and negative square root of -1. These 4 different responses just recycle themselves. So I'll just create a little chart here. This was raised to the 0. This was raised to the first power, to the second power, to the third power. This was the same thing as to the fourth power. This was the fifth. This was the sixth. This was the seventh. So if I continue this cycle, there's a cycle of every 4. By the time we get through 4 of them, it starts this cycle all over. So this will give us something to build upon for powers, for problems similar to I to say the 537. So in a different video, we'll look at exploring much higher exponents. So if you have any questions, just go ahead and post them.